Hey everybody, this is Jamie Budiff with Aviation Laser Services, and this is actually the end of the video. When I did the whole video about these aircraft parts, I'm going to explain in just a second. I went back to start editing everything and putting it together and realized the camera had came in and out of focus during a lot of the first part. So I'm redoing it. Hopefully this one will work. Okay, so I got two aircraft parts here. These are from Landing Gear, and I want to give a shout out to the AV8 group in Houston, Texas. Yoel, Mike, and the guys, thank you for sending these. Okay, so this part here is aerospace grade 7075 T6 aluminum, and this part here is probably 17.4 pH or 15.5 pH. Aerospace grade stainless steel, and the pH tells us that it's a precipitate hardening, so that means this has a temper on it. So both of these parts we're gonna have to be mindful of any heat buildup. Okay, I'll show you where they had bead blasted or sand blasted, or they did some sort of blasting on it. I'll show you a close-up of it, but in doing so, this chromated process on both of these will release hexavalent chromium into the atmosphere, into the air. Through bead blasting or sanding or sand blasting or any other way other than laser ablation. See, laser ablation, according to studies, take the hexavalent chromium that's present, and as it does its process, it converts it over into trivalent chromium, which is about as toxic as table salt. So we're going to go through these parts. We're going to do some temperature measurements on some things. We got a temperature probe here. And at the end, you'll see the end result of this. So hopefully everything else will work out. Hopefully this video won't be fuzzy. And let's get to it. Thank you. Oh yeah, one more thing. As I'm doing this process, you guys will notice that I don't wear a respirator or anything. That's just my personal preference. I can't breathe in these things. But as a laser ablation fiduciary and certified laser safety officer, it is my obligation to inform you that you should wear one of these during this process. Okay. Oh, and I wanted to mention this one thing. I'm going to be using, in all of the demos that I've been doing, I've been using this laser head this is the prototype, the original FP-300 that I built last year. This has a bigger head on it, so the newer unit, anyway, this is the smaller, lighter, newer head. On this unit, it's the same technology, the same components. We just have a different lighter head, much easier to use. So I just want to let you guys know that what the difference between the two. I've been using my original FP-300. This is the one that has the newer lighter head on it, same technology. So anyway, let's continue with this demo. Let me get this. What's really interesting here is that you can see, hopefully this doesn't mess up the camera again, if I can get into focus. There we go. I want you to see where our laser clean, right? Everything around. Looks beautiful. Where they sandblasted or bead blasted, you can tell. And I even went over this with the laser. And their sandblasting changed the surface of that aluminum. So you can see where the laser cleaning didn't. So I thought that was interesting. All right, I'm back. We got the second part here. Now this part is made out of a stainless steel alloy, and it's not the 304, the 316 alloy that we would all be familiar with. This is an aerospace alloy. It's probably a 17.5 or a 15.4, or no, I'm sorry, a 17.4 or a 15.5 alloy. A pH alloy, which means it's a precipitation hardening process that it goes through. So it is tempered, so we do have to be mindful of the heat. So on this piece, there's some sealant right here. The bulk of the sealant was removed by hand. So what they want me to see here is the coating removal and this sealant. Now, because we really have to be mindful of temperature, I want you to watch how I remove the sealant, because you have to do it in a little bit, and then you scrape it over a little bit probably, and then. So what I'm getting at is you don't want to hold the laser to it and just keep hitting it until it removes. You'll build up too much heat. So, and I put this aluminum foil here, or aluminum tape, to protect this shaft, because we will overshoot this piece here into there. So we want to just protect that. So we'll put some aluminum foil. That'll scatter the laser. It might burn it a little bit if I get it, hit it too much, but let's find out. All right, so let me get this exhaust system going, and I'll be right back. We got in all these nooks and crannies, grooves, nice and clean. Got all the sealant around here. Okay. The threads nice and clean all the way around, all inside there. Just a gorgeous piece. Okay, so bottom line, out of these two parts, this 7075 T6 aluminum piece, it took 10 minutes to get this right here, so I'm thinking the entire piece you could do in 15 minutes, 20 minutes tops, laser clean, no heat buildup, no degradation of the aluminum like the blast media did as we showed. So nice and clean, perfect, no aluminum removal, no degradation of aluminum, 20 minutes to clean with the laser. Now this stainless steel, this thing here would probably take, with the sealant, I mean we got all the sealant that was around here, we got all these nooks and crannies here on the back side, we got all that. I didn't do the whole thing of course, but to do this entire part, maybe take an hour including the sealant. Now the important thing with the sealant is you're going to need to remove most of it by hand, the big chunks. I mean thick sealant isn't just going to come right off. So you just need to scrape it with some plastic scraper or whatever you have to not damage the material. Just get the bulk off. Laser will do the rest. It got it all. So so we're looking at maybe an hour and a half, maybe an hour and a half tops, probably an hour. Laser clean this, no heat buildup as we saw. So, all right. I hope that was a good enough demonstration for you guys. I hope it showed everything that you guys were wanting to understand or wanting to know about how this would work on this equipment. And I wanted to show you one funny thing. This is that aluminum duct tape that I put around the side. I wanted to show you where it actually removed the coating of the tape, but it didn't burn it. See that right through there? It removed the coating, but it didn't burn it. It's just fine. It's actually still sticky back there. So. Anyway, if you have any questions or if I missed something you would like me to do some more on, they're just going to be here. So email me, Jamie, Jamie, at aviationlaser.com, and you can visit my website at aviationlaser.com for more information. I just put some on yesterday and this morning actually. So if you have any questions, let me know. Thank you for watching.